So now over to our next presentation by Lars Wikman. And I also would like to thank everyone. We have a lot of people in the chat. It's really fun. A lot of people giving shares and comments and questions, etc. Thanks for that. It's also that a lot of people like that you use the C64 as your first laptop. Yes, so over to Lars and his presentation. Welcome, Lars. You're soon on, Lars. No worries. Or did you mute yourself?
Yeah. Linux and Zoom, not a match made in heaven. On the mute button eventually. So I got to start out by saying thanks to Adam for sort of setting up my talk by making people really excited about Erlang. But it was really a great talk, and I think we'll have a surprising, or maybe not so surprising, amount of overlap. But yeah, I'm not super familiar with Clojure, but it's clear that there's a lot of conceptual overlap. So I think we'll get into that a bit. So I'm calling the talk Elixir and Erlang fundamentally pragmatic, and that's sort of my view on it. So my name is Lars Wikman. I do independent software consulting under the flag of underjord.io. I'm self-taught, so no computer science background. I came up as a web monkey of some sort. And I've been working exclusively with Elixir for essentially 4 years, but 3 years professionally. And I have a blog at underjord.io. I run a newsletter weekly, and I do some coding live streams where I mostly code Elixir. I'm also on the Beam radio podcast. So the Beam is the Erlang virtual machine, and that's a podcast about that. And the regular programming podcast, which me and a friend I see in the chat, Andreas, hello, run on regprog.com. So that's me and a little bit about how I got here. So as I came up in doing development and programming, I came from the web, so HTML, eventually CSS when that appeared, JavaScript, and onwards. And then I needed to do some more dynamic stuff, so I reached for Perl because that was what I found for dynamic web stuff. And then moved on into PHP because that was much more convenient than Perl, and wrangled that into a career. So I was at a web bureau for a long time. I did a lot of CMS work, all the fun stuff. And then I started to transition into Python when I realized I wanted something different. And my preconceptions of functional programming has always been sort of colored by being a self-taught developer and having no computer science background. I've been interested in computer science, but I have never done the deep dive. So functional programming seemed both complicated and very mathy. And among people who preferred other languages, it had this reputation of being inefficient, which is arguable, but that was the preconception. That was what I heard. And then we had this sense of some of it being very academic and some of it being very arcane. And I don't know exactly where I draw those lines, but some is like Haskell definitely has a reputation in the academic sense. And I think I sort of jumbled up Lisps and a bunch of others under arcane and mystical and too complex for me. And Adam actually had a slide on this. Like, there's so much theory there, or it seems like there's so much theory there. So type theory, category theory, and something called lambda calculus. And since I was making perfectly good progress with my languages of choice, I really didn't see a point of sort of complicating things, because it did seem complicated to me from where I was coming. So Elixir is what got me into functional programming. And how did it do that? Well, it's a very hands-on language. It is incredibly focused on practical usage. almost no focus on sort of conceptual purity and theoretical purity. And having spent a lot of time building sort of microservices and fancy architectures in Python, the fact that it allowed simple, relatively, concurrency and parallelism, that was refreshing. And that seemed super impressive to me, because in Python, that's a struggle. That's a performance struggle. And then it had some things that sort of made it stick out to me. So there's an IoT project called the Nerves project within Elixir that makes, if you've ever screwed around with a Raspberry Pi, this is the perfect way to screw around with a Raspberry Pi. This is the most fun way you can screw around with a Raspberry Pi. And it's also a nice way to build IoT devices. That was my path into writing a lot of Elixir. I actually ported an e-ink library from Python. And it had a clear path for web development. And that clear path had a lot of sort of rich and crunchy web features and a lot of focus on sort of near real time, which really appealed to me. So that's sort of what got me in the door and started looking at this and like, okay, I guess there's a reason for me to pass the FP hurdle. So with this, we can go back a little bit and look at how Elixir got to that point and got this particular flavor, because it's a pretty specific thing. So Elixir is a synthesis of two languages that I think importantly are primarily used in industry, or from my understanding, neither Erlang or Ruby is primarily an academic language. So Elixir has the foundation of Erlang and its virtual machine, but it sort of tries to have the appeal of Ruby, and I'll try to unpack that. So a brief history of Erlang. This will be very brief because there's so much said and written and recorded about how Erlang came about and the whole story of it being banned at Ericsson and then going open source. But it was created at Ericsson by, so commonly credited as Joe Armstrong, Robert Verding, and Mike Williams. And a lot of other people have been involved in the Beam and OTP over time, but those are sort of the original creators. And I think Robert Verding is actually trying to get Adam to come back, because there's been a fair bit of movement on Lisp flavored Erlang recently. So maybe that's something. But I think it's a very applied approach to computer science, and it tried to tackle some very hard problems in the telecom space, particularly. So Erlang was built to handle these things, and Adam covered some of them. Soft real time, so keeping consistently low latency. Hard real time is a different problem entirely, but soft real time means a reliable latency, a reliable low latency. It needed to be distributed, because this was at the point where if you wanted to add more performance to your system, you had to add another computer, because we didn't really have multi-core. So Erlang was developed in this along the lines of 70s, 80s, so mostly in 80s it was used. And later on, cores became more common, but you really needed multiple machines, and Erlang was meant to handle that. It needed to be fault tolerant, so a single error wouldn't bring down your whole telecom switch. It needed to be highly available in non-stop operation. So this is the chasing nines, which is a hard battle, but it had a design for being able to achieve nines. That's essentially nines of uptime. And then it needed to be able to do hot code updates. So you didn't have to bring down your telecom switch to update the code. You didn't have to disconnect all the calls, restart the machine, and hot code updates was the solution to that. And in my view, Erlang is about abstraction. Adam touched on this as well. So Erlang builds on the actor model. Independent entities that share nothing and communicate by message passing. It's a high-level language. Seems to be the same with Clojure. It's very dynamic by nature, and it runs on a virtual machine. This one does not run on the JVM, though. It runs on what's called the Beam. And it has some interesting foundational primitives. So you have your modules, your functions, fairly typical. And then you have the process, which is the very primitive for that the actor model in Erlang is built upon. And rather than trying to focus on sort of compile time correctness and purity in that sense, or type systems, it focuses on runtime concerns. So concurrency, parallelism, handling faults, and generally having a very, very interesting runtime use case. And it also has a wild standard library called OTP, which stands for the Open Telecom Platform, a name that's mostly odd at this point, but it's stuck. So, and in that standard library, you'll find a lot of useful stuff. You'll also find a full cross-platform UI binding for WX widgets and a lot of other wild stuff. But I think it's interesting that Erlang was never, I don't think it was ever functional just for the hell of it, or because functional seemed so much better, but by necessity. So it's not a very formal language. Again, high level, very dynamic, very runtime focused. But immutability, like Adam touched on, constrains the problem space. And that's what allowed these powerful features. So we have preemptive scheduling, where you can always preempt a running process, which means you get, that's what achieves the soft real time. That's what achieves the low latency. This is what allows hot code updates, because things don't share state in unexpected ways. This is what enables massive concurrency and parallelism, much in the same way that the PMAP example showed. And it allows the building blocks for making a system resilient at runtime. It doesn't necessarily make it resilient at runtime by default, because that's still your job as a systems builder and designer. Elixir, meanwhile, was built on Erlang by Rubists. So it compiles to the same Beam bytecode. And it was created by Jose Valim, who is a prominent Rubyist. I guess he's not much of a Rubyist anymore. He's mostly an alchemist. But Ruby and the Rails platforms, or Ruby on Rails, was always very focused on productivity, which made them darlings of the startup world, which is an industry-focused domain. So Erlang and Ruby, I find them both to be tools of industry, and Elixir marries the two in an interesting way. So what did Elixir get from Ruby? So it got the productivity focus. It got the strong tooling and sort of recognizing that developer experience is very important for success with a language these days. It also had probably a better marketing touch than Erlang traditionally has had. And that's all, I think that's often overlooked in general with programming languages. But Ruby was always good at marketing. It also gained some familiarity. There's been a lot of discussion about sort of the Erlang syntax and it being weird. And that's not a point I care to make. I don't know Erlang. I can read it okay. But if you come from sort of Python or Ruby, Elixir will be understandable. It will look fairly familiar. And it, much like Ruby, it realized it needed a web framework. So it very early on had efforts to have a strong web framework. So why would you want to use Elixir? Well, common web service requirements is distributed computing, fault tolerance, soft real-time and low latency, high availability, and deploying without downtime. Does any of this sound familiar? And both Erlang and Elixir have been proven at immense scale. So think of WhatsApp and Discord, both companies that have for a long time run very large scale services with very small teams, which is an interesting sort of dynamic. So I view Elixir as a practical synthesis of some Erlang, some Ruby, some of its own. And in summary, I like it as more than its parts. And I think it does a good job of bringing the actor model forward for the web. So with Erlang, we have the process, and Erlang's OTP, standard library, built on the process with some nice abstractions. So the gen server and supervision trees and all of that. And then Elixir brought the Phoenix channel, which is a WebSocket connection straight to an actor. And then we have Phoenix Live View, which gives us reactive web UI programming by just implementing some templates and an actor. And sort of doesn't necessitate writing as much JavaScript, which can be quite nice. So I want to show some of this because I can talk all I want about how good I think Elixir is, but I think there's sort of proof in the pudding. So let's start up IEX prompt. So IEX is your REPL for Elixir. And I prepared some code. So this is my module good processes. This, we can't go through every line of code because there's some sort of boilerplatey stuff here because I wanted to make sense when I run it. But this is a function called spawn bunch, which will spawn a count number of processes, and they will be called upon to do work. The work they will do is generating sort of 200,000 random bytes with a crypto module and sending a message back about the result. We set a time budget for it and keep track of that. And then we do a bunch of housekeeping to enforce that time budget across receiving the responses. So this is our little do work function. So let's actually spawn some processes. So I don't know what you guys typically do when you want to start a sort of thread pool or a bunch of parallel work, but I'll go with 10,000. Okay, they're done. So we have an average millisecond of 4, and we have all of the 10,000 one sent a message back. The slowest one was 6 milliseconds, and we had 994 milliseconds left. Cool. That's something. It's a little bit unclear sort of how this performs or what this actually means because we don't have any basis for comparison. But the beam by default, you can see up here, it says SMP 3232. So this is a fairly beefy machine. So it has 32 cores. And by default, Erlang will start a thread per core and a scheduler per core that it detects. But we can tell it to just start the one. And now you can see SMP and DS as 1. So if we do good processes, spawn bunch, 10,000, ideally now we would see some contention on that one CPU doing 10,000 pieces of work. And the calculated average millisecond definitely go up. So we can see that there's some contention there. And we see some of the work took 437 milliseconds because we're only running one thread. And we can see that the time left is about half a second. Okay, so I think it still does pretty good. I think that's okay. But what if we make a small misimplementation? So this is good processes, but what does bad processes look like? This is the same code, essentially. But the 13th process, now that one's a troublemaker. So that will just call do work again in an infinite loop. It's not a very good piece of work. So what happens when we run that? When we spawn these 10,000 processes again, remember we're still on a single thread. And we have a timeout for 1 second. Okay, so we can see here, we got a little message timed out before receiving all replies, expected 10,000, received 9,999. The average milliseconds, not much worse than previously. This is what soft real-time and low latency is about. But we only got 9,999 responses. So one of the processes never sent a reply during our 1 second wait time. So can we do something about that? Remember, I said Erlang is about runtime. So let's start Observer, which is a standard tool in Erlang. This is probably the reason why there is a cross-platform GUI framework in OTP. You can see here the number of logical CPUs detected and the schedulers we run. So that information is here. A lot of information is here. Load charts, memory allocators, applications, processes. So here we can see all the processes that are being run, and we can sort and look at memory usage. And this, reds, that stands for reductions. And that's how the Erlang scheduler or the Beam scheduler keeps track of work done and the amount of work done. That's what you do 4,000 reductions, which is essentially 4,000 function calls. And then it will kick you off of the scheduler for something else to do work. That's why all of our work got done in spite of the 13th piece of work going into an infinite loop. This is not what you would get with Node.js, by the way. So we can inspect this one and just take a look at what this one is, because it's a big outlier in number of reductions, and you see it keeps rising. So we can just look at stack trace, something crypto, something hash update, something hash, don't know all about that. Elixir.tools.work, that's my function for doing work. And this is bad processes. So this seems to be the one we were looking for. And we can simply kill that one. And note, like, our system has never been sort of unresponsive while this process was going haywire, because everything gets its chance at the scheduler. That's what the preemptive part is good for. So that's very, very basic actors. But let's see, the next one. So I want to show a slightly higher abstraction of the actor model. So let's actually go over to a gen server. This has a start link, which is essentially the way to start this particular actor. It can handle a few options. The most important one is an interval, and the second one is report to, which is where to send messages. And I've just decided that these exist, so it's not a sort of default thing. I've also implemented an oops function. We'll get to that one later. And def init, here you can see, so we take the interval, we take the report to, we build up our state. So actors keep state. They don't share state, but they keep it. And we say, okay, this is our state, continue and start by handling a tick. So we handle continue and tick. And what does that do? It says send a message called count after interval number of milliseconds. And we have implemented another callback up here, handle info, which will handle a count message, and it will increment the counter in the state. And assuming we have something to report to, it will send a message about what the count is. And then it will schedule the next tick. So this is also an infinite loop, but it's a nicer one because it keeps waiting before it executes. So we can do the count actor, start link, 1000. And all we get is this PID. I actually want to keep that PID. So let's just pattern match on our last command. That's how you do that. Now we have the PID. Cool. So this IEX prompt is also a process. And we can receive messages. And by default, our count actor will send to this process that spawned it. So we can use flush, which will remove all the messages in our mailbox and show them to us. So we got 26 count messages so far. And we can run it again, and it just keeps counting in the background. So what if we do count actor.oops for this PID? So what's the implementation of oops? If we handle a cast, which is a kind of call that gen servers have, we do a division by 0, which is an error. We divide 5 by 0, that's no good. And if we run that, we can see that we hit an arithmetic error, bad argument in an arithmetic expression. So it's an error. And the gen server terminated. And we can actually tell that our shell exited as well. Startlink binds your current process to the process you're spawning. This means but obviously there's something that restarted our shell, because now we're back at 1 here in the sort of execution count. And that's a supervisor. So we have a supervisor implementation. Let's look at that briefly. So this just uses the default supervisor module in Elixir. It sets up a children list with just our count actor in it, sends some stuff to it, and starts a supervisor instead. So if we do supervised, start supervised, and we go, yeah, we want the 1 second interval, and we want the name foo. That's an atom. Now we can see that we're getting these messages again every second. But if we do count actor.oops and we hit it with a name, we get the arithmetic error. So it still crashed, because that's a problem. You can't divide by 0. But it restarts. You can see the count died at 17, and now it started up at 1 again. This is the very, very basics of recovering and self-healing when dealing with the actor model. Very, very basics. So I think the next step is to show you some of the web feature set of Elixir via the Phoenix framework. So a brief visit to our router, just to show we have processes, we have counter, and then we have live. And we'll take them in order. So if I go to localhost and I go to processes, you can see that seems to run some familiar code. Let's go look at it. Page controller. This is a very, very simple controller. It handles some parameters, so I can pass it params. It turns them into an integer, and then it just does the spawn bunch thing I did earlier, and it throws the results back at you as JSON. A very, very simple API endpoint. But this is a visit to a web page which just incidentally spawns 10,000 processes and has them do work. So that's the basics. Then we have a channel. So this one is a little bit odd. So if we go to counter, we're not seeing anything there. But what's happened in the background is that a piece of JavaScript has joined this channel, which is a WebSocket connection. And it has started a count actor linked to this WebSocket session. And it has assigned that it needs to keep track of the PID of that count actor. It can handle the message count that will keep coming from this count actor, and it will broadcast that on the socket. So the state that this actor handles is the socket, and you can assign things to it, but it handles the connection to the client. It can also handle an incoming command, which is oops. This might be familiar at this point. So how do we get to this stuff? Well, this is just API side. So if we open the inspector, this is the not very visual demo of Phoenix channels. But Phoenix channels are just WebSockets, and this is just some console log on top of that. But we can still do, so this global object I implemented, we can do counter.oops. We see a crash in our IAX, and then it started again. This is not started again because of a supervisor. This is because the JavaScript just reconnected and asked for a new WebSocket, so it just started a new one. So that's the foundation for WebSocket-based actors. But Elixir has taken that a fair bit further with LiveView. And I think LiveView is a super interesting solution. So let's visit that. Page live. This is another actor, and it's very similar. There are some differences. So this has handle event rather than handle in, and but it still has handle info for receiving account. It has a mount rather than an init or a join. And this all has reasons that we're not going to cover here. But if we're connected, we start a supervised counter. We call it foo because that's convenient and it has a 1 second interval. We have the option of handling the event oops. We can handle the event run processes, which means we will run spawn bunch. So this one, it just does it all. And let's look at how we make that reach our users in our UI. This is the entirety of the markup. So let's look at what that gives us. This. So now we can see that it started counting the moment we opened this. And how much markup do we have that we need to handle? So this is a form that says how many processes do you want? And it has a Phoenix submit that sends the event run processes. So we saw that we could handle the event run processes in our LiveView actor. And there's some other sort of nice little bindings. We also have a value that we're printing out here. So in the mount, we set up a few initial default values. And here we're just accessing those assigns and printing them out with a standard Elixir template. We have the oops button, the one that says crash counter. And we have this for printing out the count and then for printing out stats. So, whoa, that's not what I was trying to do. So if we hit run processes, it runs our good processes and we get that pretty much instantly as output. So this is reactive at its finest. You just declare, like, how do we handle the state we have? And whenever you change your state, there's a lot going on behind the scenes to make that very smooth and very effective or efficient. But we can crash the counter. We get the error, but since we started it supervised, it will just restart it and keep count and go back to counting. So the way LiveView and Elixir is doing this is that they identify what parts of the template can actually change due to how you've set up the dynamic parts, the actual variables and assigns. And whenever that changes, that's recalculated on the server side, and a diff is sent down to the front end, which will use morph DOM to only patch the pieces of the DOM that you actually changed to make it as effective and efficient as possible. So the round trips are minimal and nice and tight. And this is a very, very fast way of building web applications. In all my experimentation with it, it's been magnificent. And I think it's a very, very compelling view of why sort of Elixir and Phoenix are really pushing the pragmatic angle, and why I find it compelling as an application of functional programming. For me, it's not about theory. It's not about correctness. It's about building cool stuff. It's always been about building cool stuff with me. So yeah, that's my short spiel on Elixir and Erlang as being fundamentally pragmatic. And thanks for listening, and thanks for having me.
Thank you very much, Lars. Thanks for your presentation. It was a really good presentation. I also liked your soft real-time stuff. I never got it explained in that way. This is soft, this is hard.
Yeah, so hard real-time is a really hard problem, and you need hardware for that.
Exactly. You need hardware to show the softer part of the problem, in a sense. We got a question before that actually was asked during Adam's presentation, but I think you can answer it also, or your view at least on it, Lars.
Sure.
One of the viewers asked, should you only use functional programming when there is a high complexity problem? Or should you use it at any time? What's your view? I mean, you come from Perl, so you might have a different...
So if you take a look at my live streams, I start and finish a lot of short projects and experiments with just Elixir. It takes very little time to get started. There are generators that get you a live view in a few seconds. The longest part of that script run is running npm install for the necessary JavaScript parts.
Okay.
So that, I think it's a very nice way to get started with any project. And sort of over my vacation, I spent my Fridays building on a sort of hobby project that might be a product at some point. And I think I put 40 hours into it and have something that I would be willing to dog food at this point.
Oh.
And that's building on Phoenix, Elixir, Tailwind CSS, Alpine JS, and LiveView. Plus, I'm using SQLite to really, really keep it lean. So that's an interesting stack, and I really like working with that. So I don't see a reason why you would not use Elixir for sort of web projects. Absolutely magnificent, because the runtime gives you so much for free. You don't have to worry much about concurrency. Like the Cowboy web server that Phoenix typically runs on top of is ludicrously reliable in its basic setup, and there's so much to unpack. Like if you want to know all about that stuff, I think I've ranted for a few hours over on Beam Radio, and that's probably where you should go for that. So
Yep, thanks. Another question. I assume, maybe you already done it, but will you share the examples you put out here, maybe on your homepage or blog? Or
I think I already put it public. I'll have to check.
Good. And of course, we'll share the links and everything in the meetup, and also attach it and put it in the comments.
There, it's posted in the comments.
Oh,
so it's Lavik/funprag. I think it's up to date. So.
Cool. If anyone
very rough and tumble, there's a lot more that could be done to make this an even more compelling example. I should actually credit Sasha Juric for some of the basic ideas for what I showed with regards to a single thread and the infinite loop. That's just a very compelling part of his fantastic talk on the soul of Erlang and Elixir.
Cool.
That's something worth looking at.
Are you? How many projects have you worked on in Elixir?
Let's see. So professionally, let's see. I think I'm hitting 5 right around now. And as a consultant, you tend to stick to a single project for a bit. So the count rises slowly. But a lot of people have asked sort of, but can you really work with Elixir? Isn't that a niche language? And like, you don't need everyone to be using it for you to get a job. You need one company at a time. And there's plenty of them out there. Yeah. I've actually had to turn away work. That's more the situation than anything else. So if you're curious about getting into Elixir as a career or functional programming as a career, I think Elixir is a good spot, and feel free to reach out. I can't guarantee work, but I can at least see if there's something there. So I'm very active in the community, and much like Adam noted about the Clojure community, I find it a very, very friendly community and a very interesting community. And it's small enough that you can get to know people. That's nice.
Cool. That's cool. Yeah. Thank you again, Lars, for your presentation. I think it was really good. Thank you very much.
My pleasure.
Yes, and I don't see any more questions in the chat either. I had one more question, if you're still around, Lars.
Yeah.
Do you use Elixir in the backend also when you do web development, or do you go for?
So this, whether it's full stack only, like Elixir is fantastic as a backend language. I know a lot of companies that exclusively use it as a sort of API or a language for orchestrating machine learning, which is fun. Because as mentioned, Python is not necessarily the best for concurrency and keeping track of things and making things extremely reliable in that way. But typically you need to talk to Python or something similar when you want to do the actual crunching. But Elixir is a fantastic front for that. And there's some efforts to be able to actually do ML in Elixir, which is interesting.
Interesting. Thank you very much. One more question. You talked a bit about it in the beginning, but how come you came into web development? And was it just like the end of the 90s? Everyone's doing web pages?
So this, I ran through from HTML. So AlgoNet sent out a small light so a pamphlet on HTML with our modem.
Oh, cool.
And that sort of got me. I had tried a little bit of C++, but I never got to the point where I could put a button on the screen. It was just terminal stuff. And then they wanted to teach me about sort of classes and object-oriented programming. And like I was barely a teen. I wanted to put buttons on the screen and make stuff happen. And HTML was much more approachable in that manner because it was all about putting things on the screen. So that's what got that started. And then I ran through the foundations of web and on into PHP land just in my teens when you have tons of time.
Interesting. Again, thank you very much, Lars. And we'll post all the stuff, of course, attach it to all the videos once we post them on the YouTube channel. Again, thank you for watching tonight. I have one last thing I want to say, that we'll be back on the 22nd of September with the next meetup. And after that, we plan to run a meetup once per month. So we'll have a meetup in October, November, December to keep it going. So if you want to present, or you know someone that should present, please ping them, poach them, put them in contact with me, and we'll put you on stage so you can present. With that said, thank you for tonight, and please remember to subscribe to our channel. Thank you, everyone, and goodbye.